Okay, let's take a review over the polynomials and powers. And so the first set we are going to take a look at, and we're going to name by the term and degree. So just remember, when you hear the word degree, you need to think exponent. And term, you need to think of the root or nomial. So like monomial, trinomial, binomial. Okay, so this first one, you can see that we have three terms. So this is a trinomial, and my largest exponent is a 2, so we're going to call that a quadratic. So this is a quadratic trinomial. In our second example, we have two terms. So two terms is a binomial, and we have a degree of 3 and an exponent that has a degree of 3. We call that a cubic, so a cubic binomial. In this top one, we have a single term, so that's monomial, and it has a degree of 3, so we're going to call it a cubic monomial. This example here, we have 1, 2, 3 terms. So trinomial, nomial meaning terms. And our exponent, the largest exponent is 4. So a degree of 4, we call that a quartic, like quarter or quart, meaning 4. So this is a quartic trinomial. In this example, we have two terms, so it is a binomial. Nomial means terms, but in this term, we have two variable factors. So what we have to do is we have to combine their degrees to get a total of 5, but we don't call it a quintic. If we just had x to the 5th, that would be quintic. But when you have to add exponents because the term has more than one variable, we just say this is a binomial with a degree of 5. This example, we have two terms, 1 and 2, so it is a binomial. And it has a degree of 1, so that is a linear binomial. This example has two terms with an exponent of 2. So the 2 tells us it's a quadratic, and it is a binomial, two terms. In this example, we have 1, 2, 3 terms. So that is a trinomial. And again, we have to combine these degrees, these exponents, since we have more than one variable in this single term. So that equals 4. So we don't call it a quartic, we say a trinomial with a degree of 4. So let's go through these and just identify which are not polynomials. So number 1, this first one is not a polynomial because my variable is under the radical. In this example, so this is not a polynomial. This one, the radical is over the 6 only. My variable actually has that exponent. That's a whole number. So this is, so I'll just say is, like it is a polynomial. In this example, it looks like this is not a polynomial, but once we simplify this, it brings the h to the top, making it a positive exponent. And so this is a polynomial. Here, this -2 is not a whole number, and it's up in the up in the numerator. So this is not a polynomial. In our next example, when our variable is in the denominator showing an understood positive exponent, this is not, because if we looked at this before we simplified it, it would have been originally with a -1, so this is not a polynomial. You can have a variable in the numerator and it has a positive understood 1, so this is. This exponent is not a whole number, so this is not a polynomial. And this is kind of tricky. If you simplify this, this gives us a whole number, so this is a polynomial. So when you're considering polynomials, you're looking at the exponent of the variable only, and you're looking for whole numbers, which is 0, 1, 2, 3, and so forth. So I want to make sure we understand that when we translate mathematically and write this as a math statement, anytime you see subtracted from or added to, we need to flip-flop the order. So this really should be negative 3x squared plus 6x minus 1, subtract 7x squared minus 8x plus 2, because I have this trinomial being subtracted from this one, and to subtract from something, it needs to be there first to subtract, to take away from it. Okay, now I'm going to distribute the understood positive one here, so that allows me to dissolve my parentheses. On this one, we have an understood negative one, so I'm going to distribute the negative one to each of these terms, turning each of these terms into their opposite sign. So I get negative 7x squared plus 8x minus 2. So it was like keep, change to add, and then change all these to their opposite. Keep, change, change. And now I can combine, and we get negative 10x squared. So that's my quadratic term. My linear term is 14x, and my constant is minus 3. So this is a quadratic trinomial. So again, if I had the words added to, I would also flip-flop. Now let's determine the perimeter. So we have a rectangle, and the perimeter is to add all sides. I have two sides that are the same here. So I have two pairs of sides that are the same. The notation, this notates and says these two sides are identical. And then I have these two notches. That means these two sides are the same. So when I have two of these and two of these added together. So I'm going to say 3x squared minus 4x plus 8. And then I have another length with the same measurement. And then we have two of these, the width or the height, whatever you want to call it. And I'm going to have two of those. But notice there's no linear term. So I'm going to line up like terms. So I have no linear term for the width. And now we're just going to combine. So we have 8 and 8. That is going to be 16. And so I have 16, and then we have 12. So that's going to give us 28. And then we have negative 8x. And then here we have 3 and 2 is 5. So I have 10x squared. So that's my quadratic, my linear, and my constant term. Okay, now let's take a look at some exponents. And on this page, we're going to clarify, make sure we understand which is the base and which base is raised to the power of 0. So on this one, this 0 only applies to the 2. This 3 has its own little exponent of an understood 1. So, and remember, anything raised to the 0 is 1, because that's really like just 2 over itself, which is 1. That's what the power of 0 indicates. So I have 1 over 3. In this example, the entire fraction, the 2 and the 3, is raised to the 0, so the entire expression is 1. So notice the difference between these two. In this problem, we have negative 4 to the 0. The 0 is only applied to the 4. So we have this negative, and then we have like 4 over 4. So we end up with negative 1. In this example, we have negative 4 raised to the 0. The 0 is applied to the negative and the 4. So my base is negative 4 here, and we get a positive 1. A to the 0, again, anything raised to the 0 power just means the base divided by itself, which will always give you 1. This example, my base of the 0 is only A, so my base is A. So I have a negative, and then we have A over A, so we get negative 1. In this example, we have negative A raised to the 0. Negative A is the base, so I have negative A over negative A, giving me positive 1. Here I have AB to the 0. this 0 is only applied to the b. This a has its own exponent of 1, so it just stays a, and b to the 0 is 1, so you really just have a. In this case, my 0 is attached to the a and b, so ab is the base, so I have ab over ab, which gives us positive 1. Let's go through these three. We can see these are very similar, but let's identify the base. In number 1, my base is 5. So I have 5 times 5, and I get 25. In my second example, we have negative 5 raised to the power of 2. Negative 5 is the base, so I expand the negative, and we get positive 25. In this problem, the 2 is only attached to the 5, not the negative, so we don't expand the negative, just the base of 5, and we end up with negative 25. So notice the difference. On these three, we are looking at negative exponents, and some of them have some negative bases. So this negative 2 is attached to the 5, and it's saying that this factor needs to be moved to the denominator, and then I get 1 over 25. In this example, the exponent is attached to the negative 5, and so my base is negative 5, but first we have to simplify the negative by moving it to the denominator, and we have 1 over, and we just saw that negative 5 times negative 5 is positive 25. So I have 1 over 25. In this example, my base is only 5. It is not this negative. So we have to take care of the negative on the exponent first. So we do that by flipping this entire factor to the bottom, and we take away the negative on the exponent. That's the whole point. You want positive exponents. And again, we're going to have a negative and then 5 times 5. So we get negative 1 over 25. Now this negative, you can attach it out front. You can put it up top or down below in the denominator. Okay, let's evaluate these. So we see that to the negative 4, this needs to be moved to the denominator. This 3 to the negative 2 needs to be moved to the top. And now I have all positive exponents. And so we have 3 times 3, and then we have 2 times 2 times 2 times 2. So we get 9 over 16. In this example, we have w to the 4th stays where it is, it's positive. 2 to the negative 3 is going to flip to the top, and now we can evaluate this, and we get... Pardon that interruption. And so 2 to the 3rd is 8, so we get 8w to the 4th. On this one, this 2 has an exponent of 1, this x has an exponent of 1, and the y is only attached, this negative 3 is only attached to the y. So we have 2x, and then now we have y to the positive 3. Okay, let's take a look at these last one and apply the power rule. So we have the product rule here, we're going to have the quotient rule here, and we're going to have the power to a power here. So on this one, we just have 4 times 3. You could rewrite it if you want to rewrite this. You don't have to, but we know this is 12, and then we add exponents to bases that are being multiplied that are the same, and we get negative 3. The 12 stays where it is. It has a positive 1 exponent, but we must flip the x to the denominator. That's your final answer. Now we have one where we're going to apply the quotient rule. So first we have our coefficients, and you just simplify like you learned earlier, like in elementary, and these both have a factor of 4. So we have 4 over 3, then we have x, and the rule is to subtract 5 minus negative 2, change, that gives me 7. So the x stays in the numerator, and because it's positive. Now we have a power to a power. Let's write in this understood 1, and we're going to multiply this outside power to every exponent inside the parentheses. So we really have 2 to the 4th x to the negative 12 and y to the 16th. We can evaluate 2 to the 4th, so we know that is 16. Our x to the negative 12 needs to be moved to the denominator, and then y to the 16th stays in the denominator.